Good afternoon. We're looking at math history now with the more specifics. The question of math history and using math history to inspire students is a very important question that I think is worth considering. I think that math history, the history of math, and we're talking about both the civilizations and people, specific people. Now the list of people is much longer than this, but I just picked a few people because I want to use this video to inspire someone somewhere who maybe doesn't like math to rethink about how they can learn some things from the past to enjoy it more. And if you already enjoy math, then I hope that this helps you as you see the impact that some people have had on us through mathematics. I'm going to take a step now to focus on Descartes and Newton. Now I wrote Euclid. Euclid is a very influential figure in geometry. He wrote the elements, and you can find this book online and read it and actually see some of the details from back then. But let's look at Descartes and Newton and their relationship. I was reading a book called Journey Through Genius by a professor, William Dunham, and he was talking about some of the influence or just the life of Newton. And I realized that Newton, through reading a few things here and there, Newton had a chance to review and look at some of the works of Descartes, and that helped him in getting things ready and going for what he ended up doing. Well, for getting ready to accomplish some big things. And the reason why I bring up that story is this. We, as Newton has put it in one of his famous quotes, can do some great things and good things as far as in academics and academia, but sometimes and most times this comes as we learn from the past. So when we read the works of the people of the past, they can inspire us and help us to do better moving forward. And so Descartes wrote what he wrote. He died at 54 and was a tutor to the Queen. We know some of those details. He lived back in the 1600s. Newton, on the other hand, of course, lived in was born in 1642, and Newton grew up without, his biological father. He had to learn and walk through several things, and you can read more on his life. But it's interesting just watching Newton and his curiosity and how he went and learned and went to Cambridge and he took on all these opportunities, but he didn't necessarily have the best and smoothest childhood. And so I think sometimes people look at the circumstances surrounding them and think, I can't do it, I'm not good enough, this and that. But we need to learn to persevere, we need to learn to do our best, we need to learn to make the most of the opportunities that have been given to us. And so looking at Newton's life, very interesting story. And I think that telling such a story, or with more of the details, will help children to see that they too can do it. That even if they're not prodigies, even if they're not doing calculus at the age of 7, they can work hard and use the tools that they've been blessed with to make an impact. And a quick note on Pascal, with regards to math history, we know that he invented a calculating machine of a sort to help his dad with calculations. Now you look at Pascal at the age of 18 or 19 now, who's inventing things that are used and helpful to other people. And so this reminder from Pascal's life is that no matter how young you are, you can contribute, you can make an impact, you can encourage other people. So we can learn lessons from Blaise Pascal's life, and his resume is pretty long. He died at the age of 39, but he was able to make an impact. And we name, with our pressure unit, we say 1 Pascal, which is equal to 760 millimeter mercury is equal to 1 atmosphere, which is 1.01 times 10 to the 5th Pascal. So Pascal has made an impact in our sciences. Fermat and Fibonacci, but Fermat, I'll stop with Fermat. Now we know about the famous Fermat's last theorem, where Fermat is trying to say that if you're taking, a squared plus b squared is equal to c squared. Most people know that, and that's, we say the Pythagorean Theorem, and that can also be attributed to some other earlier civilizations, but we're not going into that right now. But we know that Fermat says you can't do that for a cubed plus b cubed is equal to c cubed. You can't do that for anything greater than 2. When it's not if it's not a squared plus b squared, it will not give you a third one, which would give you the answer in the power. So like a to the 4th plus b to the 4th is equal to c to the 4th. That's one of the big things now that we know about Fermat. Fermat's last theorem, which was finally solved, or handled, I would say, and proven by a mathematician called Andrew Wiles. Now, most students do not know much about the history of where we've come from and where we're going. So I would think that we should integrate more math history in helping people get a better understanding of how math works, where it came from, and how they can make an impact. So I hope that through this video you've seen a few examples. Hopefully we can make a video for different mathematicians and just encourage people to enjoy and learn from the people of the past, the Bernoulli brothers, the Bernoulli family, the Chinese and mathematics in Africa, mathematics in South America, and all over the world, just studying mathematics, mathematics in Europe, in North America and Australia. I believe that we can take a step back, get some good books on math history, and start introducing kids to these opportunities. Thank you for watching this video, and I hope that you have been better informed on the history of math and science, and I hope that you keep watching our series on the history of mathematics. Have a good day.